Hey guys, welcome back to Data Products with R. In this video we're going to be doing dot plots, so it's kind of we're going to be merging them with the box plots that we did in the previous video. It gives us a little bit more information than a box plot, additional information to a box plot. They can get a little clunky depending on how many dots you have, so be careful what you apply these to. Again, this kind of goes to the art of visualization and knowing, what. It depends on what you think, right? So if you think it's too cluttered, then maybe just go with a box plot, or we'll look at Violin plots, which might be better for larger data sets. So let's go ahead and get into it. All right, open up your RStudio. And let's do a markdown file. We'll do HTML, and we will call this one dot plots. Very creative there. Okay. And this junk, get rid of all that. Okay, so first let's load the required packages. So of course this is ggplot2, and run that. All right, let's set our theme. So we used black and white last time. What should we do here? Theme set. Theme. We'll try dark. We'll see how that works. I'm worried that one of these is going to be real bad and make it so you can't see anything. Legend. We can always go back and change it. That's the nice thing with R. You can always change stuff. Close this off. So we set our theme now. All right. So first, let's initiate a ggplot object called TG for tooth growth. Easy breezy. TG. I'm going to call it ggplot tooth growth. First we gotta get our data, our data is tooth growth. And we gotta change the dose to a factor again, just because ggplot wants it as a factor. Okay, now what we're going to do is we're going to make a ggplot object based on tooth growth. Our aesthetic is going to be x equals the dose and y equals length. Okay, let's run all these. Perfect. Okay, let's create a dot plot with a summary statistic. Here. All right, so TG, so our ggplot object with the tooth growth data in it, geom.plot, bin axis equals y, stack direction equals center, fill equals light gray, and our stat summary is function equals mean, fun args equals list, equals 1. Alright, let's see what this does. Ooh, dark is dark. Sorry, we'll roll with it for this one. We might want to change this to light gray. Doesn't look bad, but if we change it to white, now it's okay. Well, we're rolling with it just so you can see these different ggplot themes. Okay, so as you can see here, we have our dots. So these are all of our values for 0.5, all of our values for 1, all of our values for 2. The nice thing with this is you get an idea of the distribution, right? You can see that where the mean is the black dot. So you can see there's all, this is pretty normal distribution. and it's pretty steep. This one's kind of a more spread out. This is almost a skewed, left skewed, if you turn this 90 degrees, right? So, but we can get, we can do better. So now let's try this. TG and geom box plot. And we're going to say width equals 0.5. Geom dot plot. Bin axis equals y. Stack dir equals center. And fill equals, we're going to do white because it just sticks out a little bit with that dark background. So we can have, I forgot to annotate. Let's add a box plot and dot plot together. So you can see this is a bit more information than if we were to just do a box plot like we learned in the last video. Or if we were to just do a dot plot. So we have the mean, we have the quantiles, and we have each individual observation. So you get a lot of information about how the spread of the observations are. Beautiful. Okay. So now let's do our ggplot object. Let's do a violin plot. Yeah. We're going to say trim equals false. And we're going to add a dot plot to it. Our bin axis is going to equal y. Our stack dir is going direction. Dir is going to be center. And fill equals 999,999. Is that enough? Yes. And then we're going to add our summary stat. So our function is going to be the mean, and our function argument is going to be a list of notes equals 1. Okay, so now we have a violin plot. So violin plot here is essentially, if you would rotate this 90 degrees, this would give you a better idea of the distribution. So as you can see here, this is a pretty normal distribution, right? You have the big peak in the middle and two tails. This one is a little more bimodal, where you have one peak here and kind of a peak here, or you could maybe call this a right skewed, and the same here. Okay, so now let's create a dot plot with multiple groups. All right, so we're going to take our two-growth ggplot object, and we're going to add a geom box plot, and we're going to say that our width equals 0.5. We're going to do our dot plot. Our aesthetic is going to be fill equals supplement. Our bin axis equals y. And our stack dir equals center. And then scale, fill, manual. So we're going to choose our colors, right? So we want to distinguish between the vitamin C and stuff again. So we're going to do Indian red. And we're going to do light blue. Okay. Okay, so you can see here, we have our box plot, and we have our dot plot, and when we were looking up here, we didn't know what the difference was, or which ones were VC and which ones were OJ, right? We just put them all together and said, this is what happens to teeth when you give them 0.5 of something. But now we can look and say, okay, now I know the light blue is the vitamin C supplement, the orange, or the red is the orange juice. Should have made it orange, right? That would make sense. All right, and now let's do one more thing here. So tooth growth and geom box plot. Aesthetic. Color equals sup. Width equals 0.5. Position equals position dodge 0.8. Let's close that off. Let's add a dot plot. Nope, not AB line. We'll get to AB lines, but not quite yet. Fill equals sup. Color equals sup. Bin axis equals y. Stacked dirt equals center. Dot size equals 0.8. Notice I didn't put a plus because we're not adding another like facet. This is just a continuation of the geom dot plot command. It's just a lot, and I want it to fit on a page if I were to make this into HTML. Position equals position dodge 0.8. Now, I'm going to close that off. I'm going to do a plus because this is a new facet. So you can see the indentation difference there. So we're going to fill our different colors here. We'll use the hex code. I'm going to use 00AFBB. You can use whatever you want. You can call it Indian red if you don't want to worry about typing this out, or light blue, or dark green, or you can try different words. Like I said, if you're doing this with me on Praxis, I'll have a cheat sheet for when you want to be creative. Otherwise, if you're watching this on YouTube, you can just Google hex codes, or hexadecimal, is that what it's called? Color codes. All right, and then we're going to do, for the scale, the fill and the color are going to be the same, right? So it's just the outline and the inside of the plots are going to be the same. Oops, boom, and beautiful, look at that. So this actually doesn't look terrible, right? So we got a kind of a teal and I don't know, when I wrote my notes to do all this, I don't know what my fascination was with mustard yellow. It seems like every video there's been a mustard yellow color. That's neither here nor there. But anyway, so now we've just broken it apart, right? So we have our orange juice and our vitamin C. We have the dots representing the individual observations. We have the line here, which is the mean of all these observations. We have our quantiles. We have our min and our max. So we get a lot of information here. So we can see that, okay, at 0.5, orange juice seems to do better at increasing the, well, if you want longer teeth, I guess, and you're a guinea pig, that it will grow the teeth longer. But once you get to a higher dose, then both vitamin C and orange juice seem to do the same thing. So yeah, that is the end of the dot plots. So as you can see, these provide more information, right? When you look at just the box plots that we did before, you get an okay idea. But if you're someone that is really interested in this study, you might want to see if there's outliers. Outliers can really skew things like the mean. So if you have, say you have 3 observations, right? And you have an observation of, 1, 4, and 95. And if you took the mean of that, your mean would be 33, right? 33.33. And so that 95 really skewed it. And so you will, if you just show a box or a bar graph that shows the mean, then you don't know why, if an outlier may have done that. When we get into future videos, we're going to actually use some methods to do outlier detection. You could remove outliers. You definitely want to put that in like a subscript and maybe in your figure caption or something if you are removing outliers, because you don't want to be accused of like not falsifying data, but skewing your data. Anyways, so I'm getting off on a tangent here, but yeah, so this is we're getting into more in-depth ways of displaying data, and I think this, if you were to have to do a poster or something or a presentation, this is a better way than a bar plot to display your data, because you actually have an idea of what the distribution is. All right, that's it. That's all I'm going to ramble on about now. So thanks for watching. I hope you learned something here. If you're watching on YouTube, please hit subscribe and spread the knowledge of learning R. And stick with me. We're going to be doing some more visualization techniques, some preliminary data analysis. We'll get into some R Shiny and build interactive apps in the future. So stick around, and I will see you in the next one.